This idea of a black hole just sucking up everything is definitely super scary. But is it true? Today, we'll take a look at some of the most common astronomy myths. Do stars really twinkle? What is your actual star sign? And are black holes indeed humongous cosmic vacuum cleaners that suck up everything around them? Let's see what the universe has to say about this. Welcome to Chasing Starlight. I'm Susanna Randall, an astronomer at the European Southern Observatory, ESO. As a kid aspiring to be an astronaut, I was super scared of being sucked in by a black hole. For me, black holes were kind of like cosmic monsters that zoomed around the universe, devouring anything that came anywhere near them. First, this much is true. Black holes are pretty extreme objects. They are so dense that once a certain threshold is crossed, this is called the event horizon, nothing, not even light, can escape their gravitational pull. But outside of the event horizon, it doesn't actually matter whether you have a black hole there or any other object of the same mass. The gravitational pull is exactly the same. And even if you get relatively close to a black hole in cosmic terms, not much would happen. If we replace the sun with a black hole of the same mass, then it would get extremely cold and dark in the solar system. But in terms of the gravitational pull, nothing much would change. The Earth and the other planets would stay on their stable orbits. That's because the event horizon of this black hole would be only 3 kilometers. That's actually well inside the size of our sun. And we are some 50 million times further away from the center of the solar system. However, if we did cross the event horizon, only then would we be sucked in. And even the most powerful spaceship could not rescue us. Now that is the stuff of nightmares. As a kid, one of my favorite nursery rhymes was always "Twinkle, twinkle, little star." And that was, at least in part, due to the glittering and twinkling beauty of the night sky. But as it turns out, stars don't actually twinkle. Yes, they may appear to, but what causes the twinkling is actually our atmosphere, and not the stars themselves. What happens is, as the light from the star crosses our atmosphere, due to the turbulence, it is distorted and bent, which means that the star appears slightly brighter and slightly dimmer. It twinkles. That is all very beautiful if you're planning a nice romantic night under the stars, but for astronomers, it's actually a bit of a pain, because this twinkling causes our images of the cosmos to blur. So here at ESO, we try and get the stars as untwinkling as possible. First, we choose the right sites. For example, Cerro Paranal, which is where the VLT stands. Here, the atmosphere is extremely stable, which means that the stars look like pinpoints. And another technique we can use to make the images even crisper is called adaptive optics. In adaptive optics, we make an artificial star. So we shoot a powerful laser up into the atmosphere, and by observing how this artificial star twinkles, we can correct for the fluctuations due to the atmosphere, giving us crystal clear, sharp images of the object that we want to look at. No twinkling. In Western astrology, and yes, that's astrology, not astronomy, which is what we're usually talking about, your temperament, your fate, anything that happens to you is somehow mysteriously related to your zodiac sign, which is just the constellation that the sun happened to be in at the time that you were born. I don't even know where to start on this one. First of all, the constellations are not even real in any sense. Yes, when projected on the sky, they appear to make shapes, but these stars are nowhere near each other, even in cosmic terms. But let's just assume for the moment that these constellations, as we know them, are somehow significant. Even then, we have a small issue, and we need a small physical excursion to understand this one. So, it's quite simple really. The Earth goes around the sun, and that means that over the course of a year, the sun will appear to move in the night sky along a path known as the ecliptic. And this ecliptic can be divided according to the zodiac signs that it crosses. The problem is now that our astrological star signs were thought up 2,500 years ago, when our view of the night sky and the position of the sun were a little bit different. The thing is, the Earth doesn't just spin on its own axis and go around the sun, but it also precesses. This is a little bit as if it were a spinning top. Its axis of rotation will trace small circles on the night sky. And the thing is, it does this every 25,800 years, which is why, when the astrological star signs were thought up, no one knew anything about this effect and it wasn't taken into account. What all of this means now is that our view of the constellations has changed since Western astrology was conceived 2,500 years ago. Now, on a given date, let's say the 6th of December, which is my birthday, when you look at where the sun is, it will be in a different constellation, in fact the next one, to where it would have been 2,500 years ago. In practical terms, for you, this means that if you think you're a Gemini, you're in fact a Taurus. Or if you think you're a Scorpio, you're in fact a Libra, whatever that may mean for you. In addition to the 12 classic zodiac constellations, there's in fact a 13th, a Fiacus, the serpent bearer, and that is my real star sign. Sounds pretty badass if you ask me. So there you have it. 3 common astronomy myths busted. Hopefully, the next time you're in the vicinity of a black hole, you can just sit back, relax, and enjoy the orbital ride. And in the meantime, marvel at the non-twinkling stars in the night sky with your true zodiacal match. If you enjoyed this video, don't forget to hit like and subscribe. And to be notified of future episodes of Chasing Starlight, activate the notification bell. If you have any questions, please put them in the comments below. For every episode, we will answer some of your questions.